everyone, welcome to the first video of the series Advanced Statistical Programming in R. In this video, we'll be doing some data manipulation and visualization using the tidyverse package in R. And also, we'll be working through a set of exercises based on real-world datasets like AI ML jobs, LinkedIn dataset, the latest COVID-19 India stats datasets, and top IMDb movies datasets I took from Kaggle, and you'll be able to find the links for these datasets below so that you can code with me, because I'll be coding with you instead of just explaining the code, so that it will be more interactive and engaging. And so you'll be familiar with functions like mutate and ggplot and more. I think it's time to start. First of all, let's create an R Markdown file. With these R Markdown files, you can knit them into any document you want, like this still article, HTML, PDF, for research papers, or for example, for essays you can write on Medium, or so for your code. It will be really useful because it looks really good. It shows the plots, tables, code, etc., everything you want. It doesn't show the warnings or messages if you don't want. And I'll be showing that at the end too, when we need our Markdown file. I'm gonna name it exercise 1. So you can delete these parts because we are not gonna use them. And you can delete here too. For the things I mentioned, like closing the turning off the warnings or messages, you can come here and do them. You can name these things like code chunks. You can also create Python chunks, etc. To look more into that, you can go to the visual part, and it will be easier because you can do bold, italic, etc. In the source part, you have to do this. Oh, sorry. You have to do double stars for bold, for example, but you can just do that from here. In the visual part, it is more easier. You can insert an executable start from R, Python, Bash, Julia, etc. SQL. You can insert tables, so you can code either from here or from source file, whichever you want. So let's begin with the dataset on AI and ML job listings in GSA. First, we'll load our dataset using the read.csv function from the read R package. Normally, you can do that with read.csv, which I'm going to be showing in next videos. But if you want to use just the tidyverse package, which is really good, you can just use the read.csv function. So let me show you. Let's do the read.r package and tidyverse. Normally with tidyverse, these packages should come, but you can also take them separately too, like that. And loopdate is a really good function for date arrangements if you want to turn a string into a date, for example, and I'll be showing that too. So I'm gonna be naming it job listings, and we'll just use the read.csv function from read.r. The normal function is this, read.csv. You can either use this from utils or from read.r read.csv function. And let's enter the name of it, jobs link.csv. Amazing. Now let's look at the data set. For that, you can call the head function and enter job listings. And here you can see, here is the title for the job. And then we have the location. We have published that, but there are some NAs here. And then we have the description. We have the applications count, contract type, experience level, work type, sector, and this was all. So as you've seen here, let's come here. We have the published at, and it's a date. That's good, because normally these are strings, but there are some NAs. And we can also look at the summary of the data. This is the structure. It's like a summary. It should have appeared here normally. Is it here? Yes. So here you can see it. Let me come here. So we have the titles, which is character, location character, published at date, company name character. The others are character too. Now we can continue. The date is not character. Normally, if it was character, I was gonna show you how to use the loopdate to change it. Before showing you with the loopdate function, I want to show you how to look at the NAs, like how many NAs there are. For example, for looking at the data frame as a whole, we can do sum is NA df, because is NA will just turn, let's see. Oops, sorry. I'm always missing these kind of things. It just turns false or true, as you can see here. And here you can see a true. There was an NA here, for example. And when we do sum, and then it gives us the total NAs, which is 16 in our case, so it won't we could also remove all these NAs, it won't be a problem. But I'll also show you how to look at the NAs by a column, because for that we are using another function, and that is sapply. For that we are first writing the dataset job listings, and then the function, which is in our case again the sum is .nax. So this applies this function to the job listings so that we can see the columns with the NAs. So as you can see, publish that has 12 columns with NA sector 3 and company name 1. You can use sapply for this. And another thing you can do is you can look at the NAs in rows, because normally if you remove the NAs, then you can't be sure if you'll remove 16 rows because there are 16 NAs, or if you'll remove for example 13 rows because the 4 NAs are in the same row, then your data will be reduced less basically. So to see that, you'll use apply this time, and then you enter the data job listings 1, and then the function again, which is the same function. Now when we look at it, we'll see all the rows, and you can look at the ones. And for example, this row has 2 NAs, which means that then we don't need to remove 16 rows from our dataset because one has 2 NAs, so 15 rows in total. After seeing this, I think we are now comfortable to remove all the NAs. And for that, the most used function is na.omit. For that, we just give the job listings inside na.omit. And then after that, when we look at the sum, it will hopefully be 0. Is it? Yes, it's 0. Now we got rid of the NAs too, and we can continue. I am usually too lazy to write these things and then R again, so I copy paste it and delete inside of the chunks. And in our second exercise, before going into that, although the date function is, a date, not a character, I'll show you how to use date to change these kind of things into dates. So for tidyverse package, we'll use these operators to connect different operations like chains. Then mutate function basically changes the dataset according to the function we use or operation we use, and you'll see it. And here we're gonna change the same column. Let me check which column was it again. Published at, yes, this column. When we look at it here, it's this column. We'll say published at, and then we'll basically equal that. Here we use the real equal operator, and we say ymd, and then publish that. This is really easy in comparison to the normal things we do to change it to a date. This is year, month, date as the as the date is in this format, and this just basically takes care of that if it was a character. For that, actually, it would be feasible if I did this. If I first change the dataset, change that column to string, and then we can check it from the structure, and then change it to date so that you can be sure it works. Let's say published at. And to change one data type to another, we use as.functions, and here I'll use as.character, and then let's say published at, and I'll be copy pasting this, removing this. We can look at the structure again. And here we can see now published that is really character, and we can change this. This can stay like this. Now we change it to year, month, date with date, and then apply the structure again. Look at the structure again, and here it's character. Then when we apply that, now it's date, as you can see, and the format is correct too. So this was that. Let's close these. These outputs are so long. Yep. And then we can continue. So as our second exercise, I've thought of visualizing dataset with ggplot2. For that, I'll be just showing a line, and you'll see actually I'll be showing the number of job listings according to date. Let's do that. For that, we are gonna be using tidyverse again and that operator. So job listings, then ggplot, aesthetics, and as x-axis will be giving published at, and then we'll say plus, and then for line we use geom_line. You can also put points instead of that with geom_point. And then actually I'll be adding a stat. As you can see, if you don't know a parameter, you can always read from here. So it says here the statistical transformation to use on the data for this layer. So we'll enter that count because we want to count the job listings at that date. And then we'll be adding the labs, which is basically the title of the x-axis and title of the y-axis. So date published and y, number of job listings. And let's see if this works. And here we can see how the job listings increased in in this year with 2024. It's really amazing how it increases, and we can also see it as like this in bigger format. Now let's continue with the third exercise. So in the third one, we are going to be calculating the proportion of job listings by experience level. So you'll be able to see how we use different kind of operations for data analysis, like in SQL. So I'll call it experience levels, and we are going to be using tidyverse operator again. This is, I think, called pipe operator if I'm not wrong. And we are going to be grouping it by experience level. And we just call group by function for that. And then summarize basically applies any kind of operation to that. And we could have seen the explanation there too. We go back. Here, summarize each group down to one row. So it creates a new data frame. It returns one row for each combination of grouping variables. You can read more onto these. And I'm going to be saying it's equal to count. And I'll be explaining this. And then we use the mutate again to add a new column. With mutate, you can add a new column by entering a name, for example, random name that doesn't exist as a column name in dataset, and it will be added. And for that, I'll be dividing count by sum count. To understand that, I'll have to tell you the count and I'll be doing that. So here, for each group created by group by, the summarize function summarizes the data by counting the number of rows in each group using the n function, as I mentioned. And then the result is a data frame with columns experience level and count, because we have summarized it with count and this is a new column, and then we add the experience level when we group the data set by that. And then with the mutate function and the proportion column, this adds a new column proportion to the summarized data frame, which will be the experience levels. As you can see, it's the variable name, it's the summarized data frame, which and the proportion will represent the proportion of each experience levels count relative to the total count of all groups. So this will give us a better view of how to like understand the jobs according to experience levels, like if there are more jobs in beginner level or more jobs in intermediate level, for AI especially. So let's create this, and then look at that. Now we can see it from here. As you can see, different experience levels like associate, director, entry level, executive, and their how much associate is like how much of an associate experience level the data frame consists of. And then, for example, entry level is a really high like proportion, and mid senior level is even higher. And we can also arrange that. Actually, maybe let's do that. Sorry, it was arrange, and then we put the thing we wanna do. I think so. I'll be using it with descending because I want to see the top proportion, and then it will be according to proportion basically. Let's see if it works. I hope it works. Yep, now it works. And as we can see, mid senior level has the highest proportion, then entry level, then not applicable. I'm not sure what this means, but the most job entries are mid senior level or entry level, because these are just smaller than even 10%. And now let's continue. Now we'll be analyzing the job titles, basically the frequency of different job titles to see which roles are the most common. So let's do that. Job titles, title counts, and then job listings. Now we are gonna be grouping it by title because this was the column for job titles, and then we are gonna be again summarizing it by the count of rows in each group. So as you can see, we could have just copy pasted two for different features. Whichever you want to look at a data set, you can just copy paste these and adapt it to your own problems. And then we have the arrange, and we'll be arranging it by count this time. And I want to actually take the top 10 job titles because there are a lot of job titles. And for that, I'm gonna be taking from job title counts the top 10, which I'll be doing with head function. And then we can plot it easily, but before plotting it, I want to look at it. Let's see. So the first job title with the most jobs in LinkedIn applications is machine learning engineer. Then we have AI ML engineer, which is basically similar because machine learning engineer and AI engineer similar. Then we have ML engineer too. This is the same as machine learning engineer, but as it's not like an NLP problem, we are not using any tool like that. The computer can this program can identify ML engineer from machine learning engineer. It just looks at the characters and they are different in this case. So basically we could have just added them up to the machine learning engineer, AML engineer, and machine learning engineer growth, and AI engineer. And artificial intelligence engineer is the same as AI engineer. So these can be looked at. And now let's plot it. For that, we are gonna be using this, and then the pipe operator. And with ggplot, we'll put as x-axis the title, as you can see, we're gonna be ordering it by count, reordering it by count. It will be the reverse order basically, and then in Y we have the count. It should be in aesthetics, sorry for that. Yep, now it's in aesthetics, and then we say plus geom bar, and the stat is now identity. I'll explain this after writing too. And then we have chord flip. I want to show you this because this flips the coordinates. And then labs x title, we have job title, and then as y we have the count. Now let's look at this, and as you can see, it reverse ordered it. You could have given machine learning engineer here too. You do that with minus count, reorder title. And then we have geom bar, as you can see, and the coordinates are flipped. How you can understand is that we gave x coordinate the title and y the count, but the x coordinate is the count. And then we also have the labs, as you can see. And I want to explain the stat too. So here the stat identity is used to indicate that the y values here, the heights of bars, are to be taken directly from data rather than being calculated as counts by geom bar function itself, because we already calculated the counts ourselves here in job title count, so this wasn't necessary. You can prevent this by using stat identity. Now let's move on to the other exercise, and I think we are coming to the last exercise of this part. So we have two more exercises. As I've checked my curriculum for this video, we'll be now cleaning the applications count column to extract numerical values and visualize the distribution of applications, and we'll see how we do that. So with the tidyverse function, let's do this. And then we're gonna call mutate again and create a new column which name is applications count, and then we'll say as that numeric to turn it into numeric, and we'll call the string extract function and extract. So applications count isn't a new column, sorry for that. And we are gonna extract from applications count the digits. So let me find this. We are gonna need this kind of slashes, and then a plus. This means extracting the first occurrence of digits and then turning it into numeric, because it's normally in string format. And then what we are gonna do is we are going to plot this ggplot statics, and x-axis will be applications count, and then we'll plot a histogram out of this. Let's give 30 bins, which means 30 bars will be shown. And then for labs, we'll give the names to x-axis, number of applications, and then y is normally given as frequency for histograms, as you know. Before doing that, I also want to show you how applications were before, applications count column, and after. So here is applications count. So as you can see, it was in string and it was in this format, like 51 applicants or 200 applicants, etc. And we've taken the first occurrence of the digits with string extract and extract them and converted this string into numerical format. And then we basically got these numbers, and these will be good enough normally, as you know. For example, 94 applicants is direct, and this means there were 94 applicants, but over 200 we can't really estimate. But for a rough estimation, it's better to do this way. And then let's look at the histogram too. And as you can see, most applications had more, like over 200 or 200 applicants, and there are also some with less than 50 applicants, and then the others were around these. You can also limit the x-axis to look more into 0 to 50 if you want, for example, and for that you can use xlim. For example, let's say 50. See if that works out. We have to give, sorry, 2-element vector. So it should be 0 to 50. Yep, now it worked. Sorry for that. And here you can see the applications just within the interval of 0 to 50. And as you can see, this big bulk here, after the 201, it was it had the most frequency. This had the second most frequency, and it's actually around 25 or so. So you can limit that and look at that too. Now let's continue. Now for the last exercise, we'll analyze the geographic distribution of job listings to see which cities or states have the most job openings. For that, we're gonna use the tidyverse function pipe operator again. And let me call this location counts. And then we'll group it by location. And then we'll summarize it with, again, the count of rows, like the row number, how many rows there are in each group with add function, and then again the pipe operator. And then we're gonna sort it in descending order using the count. And then I will be taking the top 10 locations. Sorry. For that, as you may have guessed, we've used this for the other exercises too. We'll call the head function and take the first 10. And then also I'm gonna be plotting this, but let's see that too. And plot that again with ggplot. Here the aesthetics, and axis, we'll use the reorder here again. Then we'll order it by location, and it will be the reverse order of the count, so it will be from the 10th element to the first element basically. So the reverse order, and then the count will be the y-axis, and we're gonna be using geom bar against that identity so that it won't be calculated again because we already calculated the count. And then we'll flip the coordinates for better visualization. And then the x-axis will be location and y-axis will be called count. Now let's look at that. in first, you can see that most have location United States because it wasn't really specified directly, I guess. But the others are specified directly, like San Francisco, CA, and it didn't take San Francisco Bay Area as the same as San Francisco, CA. That's because other thing it can't NLP. It just gives us according to difference, and these are basically different. And so this was the thing. And now let's look at the geom bar. And as you can see here, it's the coordinates are flipped. Normal location should be the x-axis, and also it gave in the reverse order. So United States should have been in the top, but we reordered it. So it looks like